initial development of a new information system is usually done as a project. A project is a planned undertaking that has a beginning and an end, and that produces some end result. So this means that the activities required to develop a new information system are identified, planned, organized, and monitored. Some projects are very formal, some are informal, usually depending on the project size. So to manage a project with analysis, design, and other development activities, you need a project management framework to guide and coordinate the work of the project team. So the Sdlc, or System Development Life Cycle, is a framework that identifies all the activities required and maintain an information system. Normally, the Sdlc includes all activities such as requirements analysis, design, implementation, testing, and evolution, as well as other project management activities that are required to successfully deploy the new information system. There are many different versions of the Sdlc. So in this lesson, we distill out 6 core processes required for the development of any new system. In other words, these 6 core processes that we will introduce here are common to all types of Sdlc. By understanding these processes, you will not only be able to develop new systems effectively, but you will also be able to adapt to any other Sdlc that you may encounter in the industry. So the 6 core processes are: first, we identify the problem or need and obtain approval. Second is that we plan and monitor the project. Third is that we discover and understand the details of the problem or need. Fourth is that we design the system components that solve the problem. Fifth is that we build, test, and integrate system components. And lastly, we complete the system test and then deploy the solution. So as previously stated in the last lesson, most information systems that you will develop are built to solve complex organizational problems, which are usually very complex, thus making it difficult to plan and manage a system development project. Fortunately, there are many ways to implement the 6 core processes of the Sdlc to handle each project's complexity. The Information Systems Development Methodology is a set of comprehensive guidelines for carrying out all the activities of each core process of the Sdlc. So later in this course, we will talk about the unified process, extreme programming, and Scrum. Most processes or methodologies now use Agile and Iterative Development. During the last 15 years, information system research efforts have resulted in many new information systems development methodologies to improve the chance of project success. These are all based on what is called Agile Development. The basic philosophy of Agile Development is that neither team members nor the users completely understand the problems and complexities of a new system. So, the project plan and the execution of the project must be responsive to unanticipated issues. The plan must be agile and flexible. Meaning to say, it must have procedures in place to allow for, anticipate, and even embrace changes and new requirements that come up during the development process. The 6 core processes are still involved in agile development, but they are carried out iteratively. Oh, what that means is that in iterative development, or an iterative development is an approach to system development in which the system is grown piece by piece through multiple iterations. So the core components are developed first, and then additional components are added. It is called iterative because the 6 core development processes are repeated. For each component. In other words, there is one big project which consists of a series of mini projects, and the information is grown piece by piece during these mini projects. Iterative development makes the agile development possible. In this figure, so it illustrates how an iterative project might be managed. So across the figure, you see 6 iterations as columns. And each iterations involves all 6 core processes as shown in rows in the table. So at the end of each iteration, a working part of the system is completed and evaluated. So the rounded mounts inside the graph represent the relative amount of effort for that core process during that iteration. What that means is that, example, in iteration 1, so it appears that this iteration primarily focus on the identifying the problem and planning the project, and lesser amounts of discovery, design, build, and test. Again, this mounts here represents the amount of effort for each iteration. For iteration 2, there is a less effort for identifying and planning the project, and more effort in the discovery, design, and build and test. In iteration 3, the build and test gets the most effort, but all 6 core processes are still involved, including the beginnings of completing and deploying the system. There are several benefits to iterative development. First is that portions of the system can sometimes be deployed sooner. If there are core functions that provide basic support for users, this can be employed in an early iteration. Second, by taking the small portion and developing it first in an early iteration, the most difficult problems can be identified and addressed early in the project. Many of today's systems are so large and complex that even with a formal process, it is impossible to remember and understand everything. So, by focusing on only a small portion at a time, the requirements are fewer and easier to solve. And finally, Developing a system in iterations make the entire development process more flexible and able to address new requirements and issues that come up throughout the project. So a key element of iterative development is dividing system components into pieces that can be completed in 2 to 4 weeks. So during one iteration, all the core development processes are involved, including programming and system-wide testing. So the result is a working part of the system. So even though it may only have a portion of the functionality that is ultimately required, developers choose components for each iteration based on priority, either the components most needed or riskiest to implement.